So, what if your development tools didn't just follow your commands, but actually learned from them? Today, we're going to dive into a dev stack that promises to do exactly that. We're talking about a system that remembers every single success and failure, just to get smarter with each project. This is the TurboFlow stack, and honestly, it might just change the way we think about writing code. Just think about that for a second. How much knowledge just disappears from a project? Every single architectural decision, every clever little optimization, every lesson you learned the hard way, it's just gone the second a team member leaves or the project pivots. But what if the code base itself could hold on to all of that memory? Well, that's the huge challenge TurboFlow is built to solve. All right, so we've all got these ridiculously powerful AI coding assistants and agents at our fingertips now. But all that power brings its own kind of chaos. You can spin up a whole team of AI agents for a task, right? But they often suffer from this thing called catastrophic forgetting, which basically means they learn one new thing and, in the process, completely wipe out what they knew before. It's a massive problem. And what does that mean in the real world? Well, without some kind of system to hang on to that knowledge, all this amazing AI-driven development feels like taking 2 steps forward and 1 or maybe even 2 steps back. Every new task has to start from square one, and all those valuable insights just vanish the moment you shut it down. This is exactly where TurboFlow steps in. You see, it's not just another collection of tools you stitch together. No, it's a fully integrated ecosystem designed from the ground up for perpetual learning. And it's built around 2 core components that work together almost like an intelligent little organization. So here's the big idea behind TurboFlow. It's an ecosystem with 2 main parts. On one side, you've got RuVector, which acts as the project's long-term memory. We're calling it the brain, because it holds on to every single lesson. And on the other side, you have Claude Flow V3. Think of it as the manager of the team, organizing all the specialized AI agents to get the work done. Let's start with the brain of the operation, RuVector. This is the neural engine right at the heart of the stack, and its number one job is to stop that knowledge loss we were just talking about. And as you're about to see, it pulls this off with some seriously impressive numbers. So how does it beat that whole catastrophic forgetting thing? It uses this really clever mechanism called elastic weight consolidation, or EWC. The best way to think of it is like a safety net for its memories. It allows RuVector to hit a mind-blowing 95% knowledge retention. That means new learning doesn't erase the old stuff, it actually builds right on top of it. But look, a great memory is pretty useless if it's slow to access, right? And that's where this number comes in. By using something called HNSW indexing, which is kind of like a super efficient digital filing system, RuVector can search its entire memory 150 times faster than the standard ways of doing it. The right info is found almost instantly. And the learning itself? It's ridiculously fast. There's a component in there called the Self-Optimizing Neural Architecture, or SONA, and it allows the whole system to adapt to new information in less than 0.05 milliseconds. We're not talking about learning overnight here. This is literally learning as you type. Okay, so what is this brain actually remembering? It's not just lines of code. It stores this rich, contextual history of the project in something called the reasoning bank. I mean, we're talking about the big architectural decisions, performance tweaks, design patterns, even links to documentation. It doesn't just remember the what, it remembers the why behind the code, the whole story. So, we've got the brain, but now we need the team that can actually act on all that knowledge. And that, my friends, is where Claude Flow V3 comes into the picture. It's the orchestration layer, the manager that wrangles a whole team of over 50 specialized AI agents. Now, Claude Flow doesn't just throw a bunch of random agents at a problem. Nope. It organizes them into what it calls agent swarms. You can think of these just like specialized construction crews, Each one has a different structure, a different purpose, and you bring in the right crew for the right kind of job. And these swarms come in 2 main flavors. You've got your hierarchical swarm, which is pretty much what it sounds like, a clear boss worker structure. It's absolutely perfect for those straightforward tasks where you have a clear plan. But for the more complex, messy problems, you call in the mesh swarm. This is more of a peer-to-peer network, where agents collaborate to untangle really tricky issues with a ton of moving parts. Okay, so we have the brain that remembers everything, and we have the team that builds everything. But how do they actually work together? Let's walk through a quick, simplified workflow to really see how this self-learning cycle comes to life. It all starts with learning. In step 1, all the initial planning docs, the architectural records, the design ideas, they all get fed into RuVector. That creates the project's foundational memory. Then in step 2, Claude Flow looks at that memory and deploys the perfect agent swarm to build the feature. And finally, step 3, the system analyzes the result, finds ways to make it better, and this is the most important part. It feeds those successful patterns right back into RuVector's permanent memory. The whole system just got smarter for the next task. And this right here, this is the magic that connects the two parts. It's called intelligent routing. RuVector's brain looks at a new task, searches its memory for similar problems it's solved in the past, and then it tells Claude Flow exactly which agent or which swarm is best equipped to handle it, all based on historical data. It literally learns who's good at what. So when you put it all together, what does it all mean? Well, the TurboFlow stack really represents a fundamental shift in how we think about our development environments. We're moving away from these static, forgetful tools we've been using for decades. And that is the real takeaway here. We are moving from a world of disposable code and forgotten lessons to a truly self-improving development lifecycle. Every single project, every task, every line of code, it doesn't just get a job done. It makes the entire system smarter, more efficient, and way more capable for whatever comes next. Which leaves us with one final thought to chew on. If your development environment could learn from every single success and every single failure, not just in one project but across all of them, what new level of innovation, what new complexity really becomes possible?